In the last video, we showcased the capabilities of Spring Boot Actuator. It exposes operational information about the running application, like health, info, metrics, etc., through REST endpoints. Spring Boot Actuator is the foundation that provides the necessary metrics for system observation. Now, let's build a comprehensive monitoring and observability stack for our Spring Boot application. Here we go. Our Spring Boot application with Actuator will expose metrics through this /actuator/Prometheus endpoint. So what is Prometheus? Prometheus is an open source monitoring system that collects metrics from configured targets, in this case, our Spring Boot application. Prometheus periodically scripts the metrics through this /actuator/Prometheus endpoint and stores them in its time series database. Grafana, which is a popular tool for visualizing and analyzing the metrics, understands Prometheus PromQL, then periodically queries Prometheus to visualize the metrics. At the same time, Zipkin, a popular open source tracer, traces requests made to our Spring Boot application. Site reliability engineers can set up alerts in Grafana, such as service is down alert, or high latency alert, or high CPU usage alert. Grafana will send out alert emails when those alerts are triggered. In this video, we choose to use Mailpit to capture these alert emails in a development and testing environment. This entire setup allows developers and site reliability engineers to monitor application health and performance, track down issues, and ensure the system is running smoothly and efficiently. All right, there are a lot of exciting things to do in this video. Let's go to IntelliJ. Since we will modify our application, we'd better start with a new branch. Git branch Observability Stack. Git switch. Let's set up Prometheus, Grafana, Mailpit, and Zipkin one by one. First, let's set up Prometheus. Let's add a dependency in pom.xml. So Micrometer registry Prometheus. Okay, and here we're going to add a scope, runtime, and click load Maven changes. So this will enable the /actuator/Prometheus endpoint. Of course, we also need to expose this endpoint in the application.yaml file. So let's go there. As you can see, we have already exposed many endpoints. And at the end, comma, Prometheus. Let's also add this endpoint to our Spring security configuration. So here. Okay, so just to recap, health info Prometheus do not need login. The other endpoints need admin role to access. Okay, so let's start our application. And let's go ahead and test in the browser. Localhost Actuator As you can see, endpoint Prometheus is exposed. So let's go ahead and click here. This endpoint exposes metrics in a format that can be scraped by a Prometheus service. Okay, what we have done so far is just for the Spring Boot part to expose this /actuator/Prometheus endpoint. Next, based on the observability stack I showed you, I need to install Prometheus on my machine. But wait, look at this observability stack. Actually, I need to install and run 4 services: Prometheus, Grafana, Mailpit, and Zipkin. All 4 services on my machine. Of course, I can manually download 4 Docker images and fire them up one by one. In this tutorial, let me show you how to simplify that process using Docker Compose. So what is Docker Compose? Docker Compose is a tool for defining and running multi-container Docker applications. It's a perfect fit for our observability stack. We'll define the 4 services that we use in a docker-compose.yaml file so that they can be run together in an isolated environment, thanks to Docker Compose. Then how do we start those services? Very simple. In the command line, just type docker compose up. One command fires up multiple services. How convenient. So let's do that. First, let's create a compose configuration file at the root of the project. docker-compose.yaml. Also, let's create a directory called Docker at the root of the project. The Docker Compose file, or the Compose configuration file, is written in YAML format and allows us to define multiple services, in our case 4, and their configurations. I have already defined them, so copy and paste. Let me explain this file. Line 2 to 7 will run a Prometheus instance exposed on port 9090, binding the configuration file prometheus.yaml from the docker/Prometheus directory. That means we need to create this configuration file. So right-click, new. First, let's new a directory called Prometheus. And then under this directory, let's create a file called prometheus.yaml. And copy and paste. In this configuration file, we're telling Prometheus how to scrape our Spring Boot application. We give it a job name. We also provide the metrics path, which is /actuator/Prometheus, the endpoint we just enabled and exposed in our Spring Boot application. Prometheus will scrape that endpoint every 3 seconds. We also provide the host and port of our Spring Boot application. In this case, Prometheus will scrape the metrics from the Spring Boot application running on my localhost machine. Many beginners of Docker Compose will write localhost 80 here. That's incorrect, since the target, our Spring Boot application, is not running inside the Prometheus container. They cannot be accessed through localhost. We need to access them through either Docker for Mac localhost, this is for Mac, or host Docker internal for Windows. Change this as you see fit. I also add a comment here. This is for demo purpose. During production, you need to change the target to the production host address. Okay, so that's for Prometheus. Line 8 to 15 will start a Grafana instance exposed on port 3000, binding the environment file from the docker/Grafana directory. Line 10 to 11 will store the Grafana's SQLite database in the docker/Grafana directory. So when we restart the container, all the configurations, dashboards, and alerts are persisted. Line 16 to 21 will fire up a Mailpit instance. As I said before, Mailpit is an email testing tool for developers that captures emails sent from the application, in this case Grafana, and allows us to view them through a web interface. This is useful for testing email notifications sent by Grafana without sending them to actual email addresses. By default, Mailpit listens on port 8025 for the web UI and listens on port 1025 for SMTP. That's why there are two ports here. After setting up the email service, let's come back to Grafana and create the environment file needed by Grafana. Since Grafana needs to send emails to Mailpit, we need to connect these two services. And we're doing that in this grafana-config.environment file. So let's create that file first. So under Docker, let's first create a new directory called Grafana. And then under this one, let's create a new file, Grafana config environment. Okay, copy and paste. The important thing here is line 2. We set the SMTP host to Mailpit:1025. Recall that Mailpit is listening on port 1025 for SMTP. You may wonder, what is this Mailpit:1025? It looks like a host name and a port. That's right. If you're familiar with Docker Compose, by default, Docker Compose sets up a single network for your application. Each container for a service joins the default network and is both reachable by other containers on that network and discoverable by them at a host name identical to the service name. Recall that Mailpit is the service name for Mailpit. Basically, line 2 will tell Grafana to send alert emails to this SMTP host. It's really convenient. And of course, first we have to enable this SMTP. We also provide the from address and from name. Change them as you see fit. Okay, let's come back to Docker Compose. Last but not least, line 22 to 25 will run a Zipkin instance exposed on port 9411. Okay, we're ready. Let's fire them up. Make sure your Docker is running. Docker compose up. The first time you run this command, Docker Compose will pull all the required images, in this case, Zipkin, Mailpit, Grafana, and Prometheus. It will take a while. Once the images are pulled down to my machine, Docker Compose will then start the containers. Great, everything's up. You can access the 4 services using these 4 URLs. Let's take a look at Prometheus first. Let's go to the browser. Localhost 9090. This is the UI of Prometheus. Recall that Prometheus periodically scripts the /actuator/Prometheus endpoint of our Spring Boot application and stores the data in its time series database. If you know PromQL, you can write PromQL expression here to query the database. So for example, let me show you a simple one. Up == 1. So here we're asking Prometheus to show us the up services. In this case, it's just our Spring Boot application. And let's click execute. As you can see, it is empty. This is because we haven't started our Spring Boot application. So let's go back to IntelliJ and start our Spring Boot application. Okay, then let's go back to Prometheus and query again. Now this time, as you can see, there's one instance, it is up. It's the Spring Boot at my local host. We can also check the health of the service by clicking here. Let's go to status and let's click targets. All right, Prometheus is now scraping one target, but you can have multiple targets. For example, the database or maybe other macro services here. So this will be a table. So we have endpoint, state is up, labels, the last scrape. Remember, we scrape every 3 seconds. And script duration, if there are errors, they will be here. And let's look at one more. HTTP server. Let's look at this one. This metric shows that this /actuator/Prometheus request took 0.113 seconds to complete. That's the maximum amount of time recorded so far. And let me make some requests. Multiple times. And then maybe something else. Okay, let's come back here. Wait 3 seconds. And then let's execute. Now this time, as you can see, we have more data because we made multiple requests. Prometheus is very powerful, but you do need to learn PromQL. The 2 examples I showed you are pretty simple, but in production, you will need to construct very complex PromQL queries. Okay. You saw how we start Docker Compose. To stop the Docker Compose, we can use Control-C to stop the containers, and then use Docker Compose down. Docker Compose down will remove the stopped containers and delete any networks created by the compose file. We don't want to stop it now. This is just for your information. Next, let's move on to Grafana. And Grafana is available at 3000. Okay, so the first time you log in here, you need to input your username and password. By default, the username is admin, and the password is also very robust, admin. And let me change a new password. Okay, now I'm in. Grafana offers various dashboards that provide visual representations of the metrics collected by Prometheus from the Spring Boot application, and I will show you some dashboards later on. Grafana gives an easy-to-understand overview of the application's health and performance. It's much better than typing endpoint URLs in the browser or Postman. Based on this slide, first, we need to connect Grafana to Prometheus. So let's go to Connections, right here, and add a data source to Grafana. Prometheus is right here. If it doesn't show, just search Prometheus, okay? And the name is good. For the connection, don't use localhost 9090. Instead, we should use the service name in the Docker Compose file, which is http Prometheus 9090. Here, Prometheus is the service name we defined in the Docker Compose YAML file. If you config the security in Prometheus, here you can provide authentication information. Okay, then let's save and test. All right, as you can see, successfully queried the Prometheus API. That means the connection is successful. Next, let's create some dashboards, right? So that's exciting. Let's go to Dashboards. And let's create dashboard. You can design a dashboard by yourself. In other words, build a dashboard from scratch for your application, or we can just find one from the Grafana dashboards website and import that dashboard. So let's go to the Grafana's website, Grafana dashboard. It's right here. The community has contributed many open source dashboard templates here, and we can just grab and use them. So let me show you some useful ones. The first one is JVM. Okay, so that's the one. So click here. And you can either copy the ID to clipboard, or download JSON and do further customization. So in this case, we're just going to copy the ID and go to the new dashboard, import a dashboard, and paste the ID here and click load. Okay, then let's first select a source, data source, which is Prometheus, the one we just set up, and import. Okay, great. Now we have this very nice JVM dashboard. Now I want to change this to last 5 minutes. Okay. Now here are some quick facts. The uptime, we have started our application for 11.5 minutes. And here is the date it started, the heap usage, non-heap usage. Here are the I/O overview, the JVM memory, CPU usage, garbage collection, memory pools, and buffer pools, and so on. And we can click into one, edit. Okay, so this is the data source right here. This, you can see the PromQL. So what's going on is that Grafana understands PromQL and will issue them to Prometheus to get the data back and visualize it to you. And this is also a good way to learn PromQL. So just click into each tile in the dashboard and look at how they write the PromQL expressions. Okay, let's go back and save. And let's save this dashboard. Okay, then let's go to dashboards and import more. The second one that I think is important is, and of course it is Spring Boot. And you can pick any one you want. Okay. So this one seems interesting, Spring Boot statistics and endpoint metrics. So let's try this one. Copy ID to clipboard. Let me paste it here. Load. And select a Prometheus data source. Import. So here we have the basic statistics, the uptime, start time, heap used, non-heap used, CPU usage, and also this is the HTTP server request count. So let's make a bunch of requests here. Just make a lot of requests within a shorter period of time. Okay, then let's come back here. Let's change this to last 5 minutes. As you can see here, there is a spike at around 7:24. That's when I made a bunch of HTTP requests to our Spring Boot application. If you move the cursor over, you'll find that Grafana uses different color codes to represent different HTTP requests. The one I'm pointing to represents the artifacts HTTP request. And let's collapse this. We also have JVM memory stats, garbage collection stats, connection pool stats, Hibernate stats, HTTP stats. Okay, as you can see here, there is a peak. Okay, I made a bunch of requests to artifacts. Jetty stats don't apply here. We're using Tomcat. Logback. Okay, so that's the overall idea. So this is the car dashboard I mentioned in the last video. It gives both the developers and the site reliability engineers insight into the deployed Spring Boot application. The dashboards are cool, but you don't want to sit in the office all day staring at those dashboards, right? We have work to do. We want to be notified when bad things happen. So let's create some alert rules in Grafana. Okay, so first let me save this. Okay, so let's go to Home. And let's go to Alerting. Alert rules. Let's create a new alert rule in Grafana. Okay, this is what I want to do. I want Grafana to monitor the health of my Spring Boot application. If it's up and healthy, that's fine, it's normal. But once the Spring Boot application is down, I want Grafana to detect that and send an alert email to the developers. To achieve that, let's define a new alert rule. But first, let's give a name to this rule. Let's call it Spring Boot service is down. Okay, in section 2, let's define a query and an alert condition. In part A, let's pick a data source, Prometheus, and let's query this metric, up. And this is instance is equal to here. So we're monitoring this instance, the Spring Boot application running on my local host. Okay, and we can run queries. As you can see in the table, that's the result. Up, instance, and this is the job, and the current return value is 1. So 1 is good, 0 means down. If you know PromQL, you can write the PromQL expression in here, but Builder is more friendly to people who do not know PromQL. So I will stick with the Builder. Okay, so that's how we query the data source. Now in part B, let's delete both expressions and create our own. So let's add an expression to define the condition of the alert rule. And we're going to use classic condition. And of course, you can use threshold, but in this demo, I want to show you this one. Okay, so when we're going to use the last function of A, recall that we retrieved some values from A. A will return a series of numbers like 1, 1, 1, 1, 1, 1, 1 means our system is healthy because Grafana will periodically query Prometheus. That's why we have a series of results. And we only want the last data point in that series. And we're going to check that number. If it's below 1, fire the alert rule. And make sure we set this as alert condition. Okay, click here. As you can see, right now it's normal because our system is up. So let's run query again. So this is 1, this is normal, everything's good. Okay. So in summary, in section 2, part A, we query Prometheus database to get a series of status of our Spring Boot application, like 1, 1, 1, 1, 1, that means up, 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 up. And in part B of section 2, we define a classic condition to decide when to fire the alert rule. So this is the condition. So if the status is below 1, we'll fire the alert rule. Okay. Next, let's go to section 3. First, we need to create a folder to store the rule we just created. So let's create a new folder. And let's call this Hogwarts Alerting Rules. And click Create. Okay. Next, let's create an evaluation group for our rule. Then what is an evaluation group? In Grafana, every alert rule is part of an evaluation group. So let's create one. New evaluation group. Let's name it prod _ service health every 10 seconds. Each evaluation group contains an evaluation interval that determines how frequently the alert rule is checked. In our case, how often do we check if the health status is below 1? Alert rules within the same group are evaluated one after the other, while alert rules in different groups can be evaluated simultaneously. For demo purposes, let's set this to evaluate the alert rule we defined every 10 seconds. And create. Okay, next, let's set this pending period to 10 seconds. So what is a pending period? If a problem occurs and Grafana detects that, the alert rule is not fired immediately. It waits for this pending period, in this case 10 seconds, During the 10 seconds, if the problem disappears, then the alert rule does not need to be fired. But if the problem continues for more than 10 seconds, then this alert rule will be fired. So that's why we need this pending period. By setting a pending period, we can avoid unnecessary alerts for temporary problems. This is really a period in which an alert rule can be in breach of the condition until it fires. If you want to skip the pending period, you can simply set the pending period to 0. This effectively skips the pending period, and your alert rule will start firing as soon as the condition is breached. Okay, let's go to section 4, and let's add a summary. The Spring Boot application is down. And we're yelling 3 exclamation marks. In section 5, configure notifications. Let's add a label. Severity. Critical. Yes, it is critical because the service is down, right? Okay, then let's save the rule and exit. As you can see, now we have one evaluation group under this folder, and this is the evaluation group. So let's expand it. As you can see, right now the state is normal. If something happened, the state would go from normal to pending and stay there for 10 seconds. If the problem continued, it would go to the firing state. Okay? But at this moment, it is normal. Next, if an alert is fired, where does Grafana send the notification? And as I said before, I really want Grafana to send an alert email to the developers. So let's go to the notification policies. There is this default policy for all alerts. You can define your own policy, but in this demo, we're going to just use the default policy right here. As you can see, in the default policy, the alert email will be delivered to Grafana default email, this contact point. And let's take a look at that. So let's go to contact points. And right now there's only one contact point, Grafana default email. And let's go ahead and edit the contact point. Okay, so this is the name. And by default, Grafana will send emails. But if you click the drop down, you can see that Grafana also supports integration to other channels like Cisco WebEx Teams, Ding, Discord, Google Chat, Line, Microsoft Teams, and one of my favorites, Slack. And here, you can actually create multiple contact points by clicking this Add Contact Point Integration. So the same alert will be sent to, for example, email, Slack, Teams, and so on and so forth. In this demo, we're only going to send it to email. And here is my fake email. So b.way. And of course, you can set those optional email settings. And let's save the contact point. Now it's time to visit Mailpit. Localhost 8025. Now, as I said before, Mailpit is an email testing tool for developers. So you don't have to send emails to an actual email server. All right, now it's exciting. Let's simulate the service is down scenario. So let's go to IntelliJ and turn off the Spring Boot application. So right now it's on. So let's turn it off. Okay. Let's first go back to Prometheus and refresh. As you can see, Prometheus detects our service is down. And let's go to Grafana. There's a delay here since Grafana depends on Prometheus. Now the alert is in pending state. This means the rule has been evaluated. Recall that we specified that the alert would go into the firing state only if it has been in the pending state for 10 seconds. As you can see now, it goes to firing. And an email has been sent to Mailpit. Let's take a look. It says Spring Boot service is down. And in the summary, it says the Spring Boot application is down. Someone is yelling at us. And this is sent from alert manager at bingyang.dev to b.wei at bingyang.dev. And this is pretty critical. Okay, let's fix that. Let's go here and start the application again. Now let's go back to Prometheus and refresh. Okay, as you can see now, our application is back online. And then let's go to Grafana. It becomes normal again. Let's go to Mailpit. And very soon, we receive an email from Grafana. As you can see, we received a resolved email from Grafana. All right, so that's all for Grafana and Mailpit. Let's move on to the next topic. Last but not least, let's talk about Zipkin. Let's go to localhost 9411. Zipkin is a distributed tracing system. Tracing refers to the ability to follow the journey of requests as they travel through various services and components in a system. A good tracer provides insight into the flow of requests through the application, capturing the latency, errors, and context of interactions between services. This is particularly important in microservices, where a single request may traverse multiple services. Recall this slide. There are two popular tracers that are supported by Micrometer tracing. They are OpenZipkin Brave and OpenTelemetry. In this tutorial, we will use Brave. Let's go to IntelliJ and install two dependencies in pom.xml. Let's scroll down. And right here, copy and paste. And click Load Maven Changes. The first dependency bridges the Micrometer Observation API to Brave. The second dependency reports traces to Zipkin, so we need both. Let's go to application.yaml file. And let's scroll down. Tracing, point 1. Okay, so make sure you don't mess up the indentation. So this is really management, tracing, sampling, probability. By default, the probability is 0.1 or 10%. This means only 10% of the HTTP requests will be sampled. But for this demo purpose, let's increase this to 1. Let me make a comment here. This is only for demo purpose. Change it back to 0.1 in production. Because if the probability is too high, this will be a burden on the Spring Boot application. But during development, it is okay to increase this number to, say, 0.9 or even 1.0. But in production, you don't want that large number. Okay, then we need to start our application again. And let's go to Zipkin. First, I want to make some HTTP requests to our Spring Boot application. So localhost, API artifacts. Let's make a couple of requests and go to Zipkins. And let's click Run Query. Let's go ahead and show the last HTTP request. Let's click Show. Here, you can see the request logs. And Zipkin tells us that for this request, for this trace, there are 6 spans. 1, 2, 3, 4, 5, 6. So let me collapse this. Then what is a span in the context of tracing? So there are actually two important terms here, trace and span. A trace represents a single user request as it moves through the entire system or a series of microservices. In this case, API v1 artifacts. A trace has a trace ID like this. A trace is a collection of spans, like in this case. We have this span, span, and span. A span is the primary building block of a trace in Zipkin. A span represents an individual unit of work done in the system. And in this case, the span really represents a method call. So when the request comes here, it first goes to security filter chain before, then inside, we verify the authentication and authorization. Then this is a secured request that gets executed, return a list of artifacts. And after that, the request will go through security filter chain after. That's the entire journey, the life cycle of a request. So here is a good analogy. The trace tells you the story of a request from start to finish, like here. So overall, it takes 47 milliseconds. Each span, in this case 1, 2, 3, is like a chapter in that story. As you can see, chapter 1 is pretty long. So chapter 1 takes 395 milliseconds out of 47. And chapter 2, which is really returning the list of artifacts, it only takes 10 milliseconds. And chapter 3 is even shorter, under 1 millisecond. As you can see, authentication and authorization actually is pretty time consuming, right? So this graph here is actually called a tracing latency visualization. You can see how much time is spent in different parts of the system. In this case, 1, 2, 3. So that tells you how to optimize your system. So in summary, this latency diagram helps engineers to diagnose and understand the flow of requests, find latency bottlenecks, and troubleshoot errors in complex distributed systems. I want to reiterate here, this tracing feature is very, very important in microservices. The benefit may not be very obvious in our monolithic application, but it's really important in microservices. Recall that to fulfill a request, we may need to call multiple microservices. If one microservice is down or throws an error, tools like Zipkin and Grafana can visualize the trace for us, help us find where the error is originating in the trace. Even better, it will present the logs to us. So based on the tracing diagram and the logs, we can quickly solve the problem. So we don't have to SSH into different microservice servers and see their logs. So this tracing diagram plus logs will help us quickly identify problems and solve problems. Everything is in one place. Our last topic in this video is Micrometer Observation API. As we all know, Spring Boot Actuator is doing a great job monitoring our application. It can monitor HTTP requests. It can also monitor repository invocations. But what if we want to define our own observations to instrument a piece of code we wrote? For example, a method that defined in the service layer. Instrumenting a piece of code is made much easier with Micrometer Observation API. Let me introduce an important annotation from Micrometer. It is called @observed. But before we can use that, we need to include one dependency. It is the Spring Boot Starter AOP dependency. AOP stands for Aspect-Oriented Programming, because the @observed annotation is actually using aspects. For your information, this dependency is optional in our project, because other dependencies in this pom.xml file have already brought in the libraries needed by @observed annotation, but it won't hurt to add this dependency in. Okay, so make sure we load Maven dependencies. Okay, let me close this. And let's go to Artifact Service class. We can use the @observed annotation either on a method to observe it or an entire class to observe all methods in it. So in this case, let's try to observe find by ID. At observed. Let's give it a name. Let's call it artifact. This name will be used as a metric name. So you can find this metric under /actuator/metrics endpoint. We can also give a contextual name. For example, this one will be find by ID service. And this name will be used as a span name, if you still remember span in Zipkin. You can also specify the low cardinality key values for this metric. Low cardinality refers to a dimension of this metric may have a limited or small number of distinct values. That's it. That is the whole instrumentation code. And you will get metrics, traces, and logs. Instrument once get 3 benefits, or 1 stone, 3 birds, powered by Micrometer. So let's give it a try. Let's run our program. First, let's go to the browser and look at the metrics endpoint. Localhost actuator metrics. And let me make a request. And let's try to access this artifact. Okay, then go back to metrics and refresh. As you can see, now we have this artifact metric. And let's try to see what this is. Great, the micrometer is collecting those metrics for us. If we added that low cardinality key values, that would appear under the available tags. Let's also go to Zipkin and take a look at the trace. So run query. This is the API request we just made. And let's click show. Okay, now as you can see, there is this new span called find by ID service. Recall the contextual name we defined. This span only took 2 milliseconds. It is the child span of this secured request span. Okay, we're done. Let's go back to IntelliJ, commit and push our code to GitHub. So let me turn off all the containers. Git add. Then git commit. Add observability stack. Prometheus, Grafana, and Zipkin to the project. Okay, git push. All right, let's go to GitHub. Let's compare and create a pull request. And here are the changes we made. We created a Docker Compose YAML file. Prometheus YAML file. We changed pom.xml. We used the @observed annotation. We changed security configuration. We also changed application.yaml file. Okay. All right, so let's create a pull request.
$2,000 later.
Okay, so the build is successful. And let's go to pull requests. And we're going to merge this pull request.
2,000 years later.
Okay, both the build and deploy are successful. As you can see, the deployment to the staging site is successful. Next, let's do a swap. Okay, swap.
2,000 years later.
Okay, successfully completed swap between slot staging and slot production. So let's close. Let's go back to IntelliJ and synchronize our local main branch. Git switch git pull Okay, we're done. Let's do a summary here. Observability refers to the ability to understand the internal state of an application from its external outputs. In a complex system, especially one based on microservices architecture, this is critical for maintaining, troubleshooting, and optimizing the application. Remember, metrics, tracing, and logging are the three pillars of observability. We used two videos to discuss the observability in Spring Boot. Spring Boot Actuator exposes various endpoints to monitor and interact with the application. Endpoints like health, info, metrics, environment, and more can be used to observe the application's state. On top of the Spring Boot Actuator, we built this observability stack using Prometheus to collect metrics in its time series database, using Grafana to visualize metrics in dashboards and send alert emails when bad things happen, and using Zipkin to trace requests. By the way, I said metrics, tracing, and logging are the three pillars of observability, but I didn't cover logging. For that, you will need to learn the ELK stack, which is a collection of three open source products: Elasticsearch, Logstash, and Kibana. Okay, hopefully you learned something about Spring Boot observability and can use it in your next project. See you in the next video.